Newton's third law of motion, action and reaction. Every move you make, every step you take, there's an invisible force pushing back with equal strength. It sounds simple, but this idea shapes the very foundation of our universe. From rockets piercing through the atmosphere to a swimmer gliding across the water, Newton's third law of motion is at work everywhere, dictating how forces interact. But how often do we truly stop to grasp the incredible power of this principle and its role in shaping our modern world? Now, think about this. Without Newton's third law, airplanes couldn't soar, cars couldn't drive, and even walking would be impossible. This isn't just a dry physics law, it's a rule that governs nearly everything around us. Today, in this video, we will explore how action and reaction work together, unlocking secrets that will forever change the way you view the simplest actions in your life. The genius of Newton and his laws. Before exploring Newton's third law, it's essential to understand the man behind it. Sir Isaac Newton, born in 1643, was not only a physicist, but also a mathematician and astronomer. His work shaped classical mechanics and transformed how we understand the universe. Newton's Philosophia Naturalis, Principia Mathematica, introduced the three laws of motion, each playing a vital role in science and engineering. The third law, which we'll focus on, is often seen as the foundation of motion. Why? Because it highlights the balanced nature of forces, the idea that every action has an equal and opposite reaction. Understanding this principle isn't just for scientists. It helps explain the mechanics behind countless everyday activities. Breaking down the third law, what does it mean? Newton's third law states, for every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. This law emphasizes interaction. Forces don't exist in isolation. For example, when you push against a wall, the wall pushes back with an equal force. If this weren't true, you would move through the wall or be thrown backward with unbalanced force. Here's a relatable example. Picture a swimmer gliding through the water. As they push back against the water with their arms, the water responds by pushing them forward with equal force. This isn't just some coincidence, it's the action-reaction pair in full effect. Without the water pushing back, the swimmer would stay stuck in place no matter how hard they tried to move. This perfect balance of forces not only keeps them afloat, but also allows them to propel forward with each stroke, showcasing the beauty of Newton's third law in action. Everyday examples of action and reaction. Newton's third law isn't confined to textbooks, it's everywhere around us. Walking. Think about walking. As your foot presses against the ground pushes back with equal force, propelling you forward. This reaction force is so natural that we rarely notice it, yet without it, taking even a single step would be impossible. Bird flight. Birds use Newton's third law every time they take flight. As they push their wings downward, the air pushes back upward, providing the lift needed to stay aloft. It's a harmonious interaction that lets them soar gracefully through the sky. Car tires on the road. Next time you're driving, pay attention to the magic happening beneath your tires. As your car accelerates, its tires push backward against the road, creating an equal and opposite force. In response, the road pushes your car forward with the same strength, allowing it to glide smoothly ahead. This invisible balance of forces is what makes every drive possible. Whether you're cruising down a quiet street or zooming down a fast-paced highway, Newton's third law is at work, silently powering every journey you take. Now, here are questions for you. How often do you notice action and reaction in your daily life? How do you think this law might change the way we approach technology in the future? Drop your thoughts in the comments below. We'd love to hear from you. The physics behind the principle. Let's delve deeper into the mechanics of action and reaction. Forces are vectors, meaning they have both magnitude and direction. When an object applies a force, it experiences an equal force in the opposite direction. These forces act on different objects, ensuring balance and consistency in interactions. For instance, consider a ball hitting a wall. The ball exerts a force on the wall, and the wall exerts an equal and opposite force on the ball, causing it to rebound. This principle ensures equilibrium, maintaining the harmony of motion in the physical world. Applications in technology and engineering. Newton's third law is not just a theoretical principle. It's a fundamental force behind much of the technology we rely on today. From the engines that power airplanes to the sports we enjoy, this law shapes the way we interact with the world in ways we often take for granted. Jet engines. One of the most impressive applications of Newton's third law is in jet engines. When air is expelled backward at high speeds from the engine pushes forward with an equal force. This backward force generates the necessary thrust that allows airplanes to lift off the ground and soar through the skies. Without this fundamental principle, modern air travel as we know it would be impossible. Firearms. In firearms, the principle of action and reaction is evident when a gun is fired. As the bullet shoots forward out of the barrel, the gun itself experiences an equal and opposite force: recoil. This recoil, though uncomfortable for the shooter, is a direct and powerful demonstration of Newton's third law. It's a reminder that every force we exert, no matter how small, has a counterforce working against it. Space exploration. Space exploration also relies on Newton's third law, especially in zero-gravity environments. In space, astronauts can't push off the ground like they would on Earth. Instead, they push against objects or use small thrusters to generate an equal and opposite reaction. By pushing against something, whether it's a wall, a spacecraft, or even just the air, astronauts can propel themselves in the opposite direction, moving through the vastness of space with precise control. Newton's third law isn't just an abstract concept. It's a powerful force that drives the technology we use daily, shapes the sports we play, and even allows us to explore the farthest reaches of space. Historical experiments and demonstrations. One of the earliest experiments showcasing the third law involved the use of carts on tracks. When two carts were pushed toward each other, their equal and opposite forces demonstrated the action-reaction pair. Over time, advanced demonstrations like pendulums and collision experiments have proven the universality of this law. Schools and universities often use these experiments to make physics more relatable and engaging. How Newton's third law shapes our understanding of the universe. The third law extends beyond Earth. It governs celestial motions, such as the gravitational interactions between planets and moons. It also explains the behavior of particles at the atomic and subatomic levels, where forces like electromagnetism operate. Even in philosophy, the idea of action and reaction has inspired discussions about balance and causality. Newton's insight transcends physics, highlighting the interconnectedness of all things. Conclusion. Newton's third law of motion isn't just a principle of physics, it's a lens through which we can view and understand the world. From the smallest particle to the grandest rocket, this law reveals the elegant balance of forces at play. So, the next time you take a step, watch a bird fly, or marvel at a rocket launch, remember the genius of Newton and the profound simplicity of his third law. It's a testament to the idea that for every action, there's an equal and opposite reaction, a principle that shapes not just motion, but our understanding of the universe itself. If you found this fascinating and want more content that helps you see the world in a new way, don't forget to like, share, and subscribe.